Hey guys, today we'll be talking about the section 1.7 entitled Functions. If you remember last section titled Relations, we had a set of ordered pairs that you see down below. We had tables, we had mappings, and we had a bunch of graphs. Remember, relations is a set of ordered pairs. It's basically different ways that you could group together some data by using ordered pairs, a table, mappings, or graphs. A function is a very special type of relation. It's a relation in which each element of the domain is paired with exactly one element of the range. Remember last section when we talked about the two terms domain and range? Domain were all the x values in a relation, and the range was all the y values. A function has one specific y value for each x value. Another way I like to explain what a function is by just talking about this example here. Let's say I asked you guys to find the value of y if x equals 2 for the equation y equals x plus 2. Well, what we would do was we would say that y equals, and we would substitute x equals 2 and for x plus 2, and you guys would tell me that y would equal 4 when x is 2. If I were to do this same exact problem again, we would do the same work. If I wanted to find the value of y, if x was equal to 2, we would say y equals 2 plus 2 and get the same exact answer, y equals 4. That is exactly what a function is. It means every time you plug in the same x value, you will get the same y value. We could organize this data, just like last section, as ordered pairs, tables, mappings, and graphs. Not all relations are functions, okay? So we're going to go through each of the relations below and determine whether it's a function or not. The first thing you want to look for is repeating x values. So we're going to take a look at this first set of ordered pairs here. These just 4 ordered pairs, that's one relation. And we're looking to see if there are any repeating x values. Remember, x values are the first value in an ordered pair. So the first x value is 3, the second x value is 4, the third x value is 1, and the last x value is 0. There are no repeating x values, therefore this one's actually very easy. You're going to say, yes, this is a function. It's a very special type of relation. Each x value has one y value. Now let's take a look at the second relation, the second group of ordered pairs. Again, let's check out to see if there are any multiple or the same x values. So we have x value of 3, x value of 4, x value of 3, x value of 6. Did any of the x values repeat? Yes, they did. We had an x value of 3 repeat twice. Now, for every x value, you have to have the same y value. Do they happen to have the same y value for the same x value? Yes. What this is saying is that they plugged in 3 into an equation, x equals 3, and got y equals 4. Later on, they did the same problem, x equals 3, and again got y equals 4. This makes sense, just like the problem we did above. For every x value you plug in, you'll always get the same y value. So this too is a function. This last example for our set of ordered pairs is an example that a relation is not a function. Again, let's look to see if there are any repeating x values. X is 3, x is 1, x is 3, x is 6. Are there any repeating values? Yes, there are. Again, 3 repeats, and we're only looking for the x values that are repeating. Now, if it's a function, they would have the same y value. When they plugged in 3 the first time, they got y is 4. And when they plugged in 3 the second time, they got y is 2. That does not make sense. That is not what a function is. A function says that for every x value, it will have the same y value. the x value of 3 has two different y values here. Therefore, we're going to write no, this is not a function. We are essentially going to have the same idea going further for the tables, the mappings, and the graphs. We're just going to be looking at the data in a different type of relation. So let's go ahead and move on to the tables. Let's look at the first table and check to see if there are any repeating x values. We have x is 1, x is 2, and x is 1 again. So are there any repeating x values? Yes, there is. If it's a function, the y values will be the same for these x values. If it's not a function, they'll be different. So the x value of 1 has a y value of 3, but then the x value of 1 has a different y value of 5. Therefore, this is not a function. Remember, the directions say, determine whether each set of relations are functions. All right, so this is not a function. Let's go ahead and look at the second table. Let's check for any repeating x values. There happens to be a repeating x value of 1. If the y values are the same for the repeating x values, then we say yes, it's a function, but if they're not, like the first table, then it's not. Since the x value of 1 has y value of 3, the same y value both times, we're going to say yes, it is a function. And lastly, let's check to see if there are any repeating x values in the last table. In this case, there are not, and this is the easiest type of relation to determine whether it's a function or not, because we could just say, yes, it's a function right away. The x values aren't repeating, therefore, there won't be different y values for the same x value. Let's take a look at our third part here, our mappings, right? Let's see if there are any repeating x values, meaning there's one x value mapped to one y value. For 1, it's only being mapped to one y value. The number 2 is only being mapped to one y value. And 3 is only being mapped to one y value. So that is like our last table in which none of the x values repeat. So we're going to say yes, this is a function. Let's move on to the second mapping and see if any of the x values are repeating. This 3x value is repeating because it is going to two y values. If I wanted to make two ordered pairs for that, we would say that the ordered pairs were 3, 1, 3, 2, and the last ordered pair would be using the x value of 4 as being mapped to 2 as well. Are there any repeating x values? Yes, there are. 3 is repeating. And as you could see clearly in the mapping, it is being mapped to two different y values. It's being mapped to 1 and it's being mapped to 2. The same x value has two different y values. Therefore, this example is not a function. When we're dealing with ordered pairs, tables, and mappings, the idea is pretty much the same in testing whether it's a function or not, looking for repeating x values. However, when we look at the graphs below, it's a little bit different, and we're going to use what's called the vertical line test. This vertical line test helps us figure out whether graphs are functions or not. And if you remember, the vertical line test says if you draw a vertical line anywhere on the graph and it hits the graph more than once, it is not a function. So for example, our first graph, our line that is increasing, our red line in the first graph, if I draw a vertical line anywhere on this coordinate plane, will it ever cross the graph or that red line more than once? No, it would not. So yes, this is a function. If it were to cross that line twice, then we would say no, it is not. For example, the second graph, if I draw a vertical line anywhere on this coordinate plane, will it ever cross the circle more than one time? Yes, it will. It will cross 2 times actually for many vertical lines that you might draw. Therefore, we will say no, it is not a function. Let's take a look at the next two. If I were to draw a vertical line on this graph anywhere, will it ever cross the red graph more than once? No, it will never cross more than once, so it is a function. And lastly, if I draw a vertical line on this graph, will it ever cross the graph more than once? Yes, it will. It could cross the graph twice for the vertical line I just drew. Therefore, it is not a function. So that's the first part of this lesson, determining whether a relation is a function or not. The second part is evaluating functions. So this is when functions are in equation form, and we look at something called function notation. So function notation, right here, the way you would say that is f of x equals 3x minus 8. That is the same equation as y equals 3x minus 8. As you could see, instead of a y, we replace it with an f of x to show that yes, it is an equation and it also is a function. We are going to evaluate these functions given different values to plug in for it. So for number 1, they want us to plug -2 in for the x of the function that they give us into the directions. So what we're going to do is we're going to write f of 2 would equal 3, and instead of x, we're plugging the -2 in for the x, minus 8. This left side, the f of -2, is just saying what we're plugging into the function and what it would equal. So we're going to repeat to say when we plug in -2 into the function, we will get, and on the right side, we want to evaluate using the order of operations. So we will do the multiplication first to get -6 minus 8. And lastly, again, we're going to restate when we plug -2 into the function, we get -6 minus 8 would give us -14. This right here is actually our answer. The value we get when you plug -2 into the function in the directions they give us, you would get -14. Let's do another one for this function. This is asking us to plug 1 into the function and then add 4 onto the end. So using our function in the directions here, we're going to say that that would equal 3 times, they want us to plug 1 into the function, so 3 times 1 minus 8, and then we're going to add 4 onto the end of that. Just like number 1, we are going to continue to copy that left side, saying when we plug 1 into the function and then add 4 at the end, we get, let's use the order of operations to simplify this. Everything in the parentheses will go first. So we'll multiply. 3 times 1 is 3, minus 8 plus 4. I'm restating again, when I plug in 1 and then add 4, we're going to get 3 minus 8 happens to be -5 plus 4. And lastly, our answer is when we plug 1 into the function and add 4, we get -1. -1 is our answer, and everything to the left of it is just restating what we did with the function. We plugged 1 into the function and added 4 onto the end of it. Our answer is -1. Sometimes they will change the function up. For example, the second half of our page, the new function is g, the name is g of z, equals z squared plus 3z minus 4. Notice that the new variable is z, and it appears twice on the right side. The name of this function is g of z. It's a function g for the variable z. So what they want us to do in number 1 is they want us to substitute 2 into the function. And now remember, there are 2 variables, so we have to substitute 2 in twice. So when we substitute 2 in, we'd get 2 squared plus 3 times 2 minus 4. Let's go ahead and take the next step. When you substitute 2 into the function, we're going to get 2 squared is 4. We're going to do exponents first. The next step we'll do is the multiplication. We're following the order of operations, so 4 plus 6 minus 4. When we substitute 2 into the function, we're going to do the addition to get 10 minus 4. And lastly, we'll arrive at our answer. When we substitute 2 into the g function, your evaluation or your answer will be 6. Just like number 3 in the first section, number 3 in the second section is now going to ask us to substitute a number into the function and then add 1 onto the end. So here we go. When we substitute 3 into the function and then add 1, what it's going to look like is the following. We're going to have 3 squared, and remember, we are following this function in the directions right now. We would have 3 squared instead of z squared plus 3 times 3. Remember, we're substituting it into both of the variables, minus 4. We're going to then take that and add 1 onto our answer. So again, when we plug 3 into the function and add 1, we're going to get, let's simplify everything in the parentheses, and I'm actually going to do a couple steps at the same time. The exponents would go first. 3 squared is 9, because it's 3 times 3, plus 3 times 3 is 9, minus 4, plus 1. The next step we would do is still everything in the parentheses. However, we're going to add the 9s to make 18. Minus 4 will be 14, plus the 1 on the outside, in which we'll arrive at our answer. G of 3 plus 1 equals 15 would be our final answer. What I'd like you guys to do, after you take the notes and copy down these first 4 problems we did, I would like you guys to try the even problems now. Remember, these 2 problems at the top section is following along with this function in these directions, and the 2 problems in the second section is following along with this function in those directions, okay? So what I'd like you guys to do is pause the video and try 2, 4, and 2 and 4, all the even problems. They are very similar to the ones next to it. So if you could do it right next to it in your notes, that would be for the best. Once you're done, play the video for the answers. So here are your answers for the even problems. The first section, we're following along with this function here, and number 2, they wanted you to substitute 6 into the variable. So we would have 3 times 6 minus 8, in which we would get our final answer as 10. If you wanted to restate your answer, we would say when we plugged in 6 into the function, we got the answer 10. Number 4 wanted us not only to substitute -2 into the original function in for x, but then they also wanted us to subtract 2 on the end of that. So the problem would be 3 times -2 minus 8. We would do everything inside the parentheses first to get -14, and then when you subtract 2 from that, we would get -16. The next section, again, wanted you to use this new function here, in which you have to remember there are 2 variables you want to substitute in for. So number 2 wanted you to substitute -1 in for the variables, in for z. So as you could see, we substituted it in for twice for the 2 z's that appear in the function. When you square -1, you're going to get +1. 3 times -1 is -3, and then -4. We're moving left to right. 1 minus 3 is -2. -4 will give us our final answer of -6. And lastly, I needed just a little bit room on the bottom here. Number 4, I wanted you to substitute -2 into the function and then subtract 3 onto the end of it. So as you can see, you substitute -2 in twice. You want to do everything in the parentheses first and then subtract the 3 on the answer last. You're going to square -2, which will give you a +4. 3 times -2 is -6, minus the 4 on the end. 4 minus 6 minus 4 is -6, and then minus the 3 will give you your final answer, -9. Please let me know if you guys have any questions.